In this video, we are going to explore Lewis dot structures and the octet rule. A molecule's chemical behavior is determined by its structure and three-dimensional shape. This is a very important concept, and it's the foundation of how biomolecules function. Structure determines function. So how atoms are connected? Which atoms are bonded together and what types of bonds are present will define a molecule's structure. It is also useful to know which valence electrons participate in bonding and which do not. Lewis dot structures take into account the valence electrons, both those that form bonds and those of which are non-bonding. So by now we should be comfortable with the representation of a single bond with one line, a double bond with two lines, and a triple bond with three lines. Each line represents 2 electrons. So a double bond has a total of 4 electrons, and a triple bond has a total of 6 electrons. So remember, each one bond is 2 electrons. Atoms in Lewis structures obey the octet rule. What this means is that atoms are most stable when they have a complete valence shell with 8 electrons. The exceptions to this are hydrogen and helium, which have a stable valence shell when they have 2 electrons. So here I've taken the steps for drawing Lewis structures from your text. The first thing you want to do is count the total number of valence electrons. Okay. In order to do this, you can look at the group number for the atoms. Then what you're going to do is you're going to write the skeleton of the molecule, showing only the atoms and the single bonds required to hold them together. If you are not given how the atoms are connected, the central atom should be able to make the most bonds and be lowest in electronegativity. Next, you're going to subtract 2 electrons from the total in step 1 for each single covalent bond that you draw in step 2. With the remaining electrons, you're going to distribute them as lone pairs. Add lone pairs starting with the outer atoms and then work your way inward. Again, the outer atoms should be more electronegative. You always want to try to achieve an octet. If there is an atom with less than an octet, increase the atom's share of electrons by converting lone pairs into bonding electrons. Here you are going to create double and triple bonds. Now there is always an exception to a rule. Not all atoms have a complete valence shell. Boron is electron deficient. So if we look at BH3, so let's do step 1. We are going to count the total number of valence electrons. We will see that boron is in group 3, so it has 3 valence electrons. Hydrogen is in group 1. It has 1 valence electron, but there are 3 of them, so we need to multiply by 3. So our total number of valence electrons here would be 6 valence electrons. Boron can form 3 bonds. Hydrogen can only form 1 bond. So we have boron as the central atom. We add our single bonds to connect the skeleton. If we count our if we count our electrons, we'll see that we have 2, 4, 6. So we have our total number of valence electrons. And you can see boron does not have an octet. So let me just draw this again. Okay, so what we can see here is that boron is electron deficient. Sulfur, which is in the third row of the periodic table, where N equals 3, is also an exception to the octet rule. It has a valence shell that can hold up to 18 electrons, and therefore sometimes has a Lewis structure that exceeds the octet rule. In organic chemistry, we primarily look at atoms in the second row of the periodic table, where N equals 2. These atoms do not exceed the octet rule and cannot have more than 8 valence electrons. Before we conclude this video, let's work on a problem. So here I've taken a book problem 1.9. The problem says, for each structure, determine whether it is a legitimate Lewis structure. If not, explain why not. Let's look at the first structure. We have 3 carbons and 4 hydrogens. So step 1 would be to determine the total number of valence electrons. So carbon has 4 valence electrons. Multiply that by 3. That's a total of 12 valence electrons. There are 4 hydrogens. Times that by 1. There would be 4 valence electrons for a total of 16 valence electrons. So now let's look at our skeleton. We see we have carbon as the central atoms because carbon can form the most bonds. Okay. Let's count the total number of electrons that are present. We have 2, 4, 6, 8, 10, 12, 14, 16. So this is a valid Lewis structure for this molecule. Let's look at the structure below. Let's do step 1. Let's count the total number of valence electrons. So we have 2 times 4 for 8. That would be for our carbons. We have 5 valence electrons for our nitrogen. We have 2 hydrogens times 1. That would be 2. And we have 1 oxygen, so that would be 6 valence electrons times 1. Okay, let's total this up. 13 plus 8 for a total of 21 valence electrons. If we look at the structure, we can see right off the bat that this structure is incorrect because here we are violating, as I showed you in red, you're violating the octet rule. Remember this now. You can only have 4 bonds to carbon. Carry this with you throughout the entire semester.